Welcome to Math Monday. Today the topic is how many ways can you scramble your name? And we're going to do some counting. It's a topic called combinatorics that a lot of people never get to college, but if you know how to multiply, you can do it now and it's a lot of fun. So I don't know about you, but I really enjoy wordplay. There's an example on the screen of taking the name TESSA and rearranging it to make another word. It'll make the word seats. There are some other words it'll make. Let's get into it. So TESSA, rearranging the letters of one word to make another word, is an example of it's called an anagram. So do any of you have any favorite anagrams of a word or a phrase that turns into another word or phrase? Anybody have any favorite anagrams? Okay, well, I'll show you a few of mine. Here's some of my favorites. So listen turns into silent. And then if you're a Harry Potter fan, you probably know this one. There's a character named Tom Riddle, and his whole name, Tom Marvolo Riddle, is an anagram for I am Lord Voldemort. And that's something that Joe Rowling planned. Ocean turns into canoe. That's really cool because the two words are related. And supersonic turns into percussion. I didn't know that one until I did a search this morning for cool anagrams. Okay, so let's start with the basic question. So how many ways can you scramble your name? Let's start with a really simple name. My last name is Kim. It's also some people's first name. Here's one, it has 3 letters. Can somebody, I'm gonna call on different people, each person can go once. Please tell me a different order in which I could write out the letters K-I-M.
Does it have to be a real word, or can it just
no,
be like a real?
it can be. It doesn't
okay.
have to be something you can pronounce.
I-K-M.
It's okay. I-K-M. Okay. What else? Looks like Hannah and Serena.
Mick, M-I-K.
Okay. Let's do that.
I-N-K.
Yeah, good. I-N-K. Okay, who else has got one? Are there any more?
M-K-I.
M. Okay, good. Is that it? Anybody find any more, or are we done? Okay, it looks like
to be one more because there's 6.
Yeah.
So it's gonna be K-M-I.
K-M-I. Yeah, one more. And how did you know there were 6?
Because if you look at them, so like if you look at them in one by one, for the first place where Kim, like where the K is, you can choose from K, I, or M. So
that's right.
You have 3, and then from the next.
We're having a little trouble hearing you, but I got the idea. Yeah, so the first place can be a K, an I, or an M. That gives us 3 groups. We can look at it this way. So K, once you have a K, it can be IM or MI. And once you have an I, it can be followed by KM or MK. So that's a total of 3 times 2 ways to do it. And of course, if you've got a 3-letter name or a 3-letter nickname, you also have 6 orders. Okay, good. We figured that one out. That's the number. Different orders are called, the mathematicians call these permutations. So these are all permutations of the letters K, I, and M. To permute something means to rearrange its order. Okay, now we're going to try, I'm going to give you a chance working in groups. We're going to put you in groups of 3, and I want you to find how many permutations, see if you can list all the permutations of these letters, S-T-O-P. So did anybody, any group want to talk about how many permutations they found for the word stop? Oh, Serena? Yeah, go ahead, Serena.
Pots.
And speak up so everybody can hear you.
I got pots.
You got pots,
I got post.
post. Yeah, these are some of the words you can make. Anybody else get any other words?
Yeah. Opt, ops.
Yeah, that ops, definitely. And then Hannah?
Tops.
And Suhita?
Is it a real word thingies?
It doesn't have to be a real word.
Okay, so TPOS.
TPOS. So I have a question. It was, I guess I wasn't which is how many, these are some of the orders. Some of you, there's one more word, by the way.
Thought.
What is that?
Thought.
Yeah, that's right, spot. So there's 6 words. How many orders are there altogether if they don't have to be words?
23 or 24.
24.
And okay. Now, Jed, I know you know the answer. Somebody else answered. Who else answered? Did somebody else answer 24?
Yeah, Hannah did.
Hannah did. Tell me about, okay, can you spotlight Hannah? And Hannah, please tell us about how you found 24.
Well, there is 6 words for each letter, the first letter. So like T, there is 6 words, P, there is 6 words, and S has 6 words, and O has 6 words, because each second letter has 2 words with it, and then with that first word.
Awesome. So there's four possible first letters, and then with the 3, we already figured out with 3 letters, you can make 6 different orders.
Mm-hmm.
So that's 4 times 6. That's 24 altogether. So I have a question. If I had, maybe you can answer, Hannah. If I had 5 letters, how many orders would there be?
Wait, so you're asking for 25 letters, right, in a word?
Yeah.
Well, so that would be 120 permutations.
And how do you get 120?
5 factorial.
5 factorial. Can you explain it so everybody, other people don't know what factorial is? Can you explain what that is?
So it's 5 times 4 times 3 times 2 times 1, but you leave that out. But because there's 5 letters you can put in the first place, 4, 3, 2, and 1.
5 places, yeah, just like Hannah said, there are 5 letters you could put in the first place, and then the remaining 4 letters, we already figured out it was 24, which is 4 times 3 times 2 times 1. Okay, that's cool. This stuff is hard, so we're going to go through it several different ways. So here's another way of looking at it. 1,234 is a number that's made out of the digits 1, 2, 3, 4. Now here's a question. I'll just tell you, that's the smallest number you can make with 1, 2, 3, 4. So here's the next question. Can somebody tell me what's the largest number you can make with those 4 digits?
4, 3, 2, 1.
4, 3, 2, 1. And how'd you figure that out?
Well, you want to put the largest digit in the bigger, in closer to the left. So you just do that in decreasing order, 4, 3, 2, 1.
Right. Okay. So let's give somebody else a chance. What's the next number after 1,200, the next largest number you can make out of 1, 2, 3, 4 after 1,234? Anybody got an idea? I'll stop sharing and what do you think?
I got 3, 4, 2, 1.
3, 4, 2, 1. Okay, let's see. I guess I have to go back to share my screen sharing. I shouldn't have unshared. 3. Okay, Suhita has 3, 4, 2, 1. Can somebody find a number smaller than 3, 4, 2, 1 that you can make? We're going to find the smallest number that's not 1, 2, 3, 4. Yeah? What do you think?
2, 4, 3, 1.
2, 4, 3, 1. Yeah, that starts with a smaller digit in the thousands place, so it's definitely smaller. But I bet you can get even smaller. Anybody have an idea?
1, 3, 2, 4.
1, 3, 2, 4. That has a 1 in the first place. So we just found out that you can get smaller by having a 1 in the first digit in the thousands place. Well, it's a question. Can you get any smaller? Yes, Hannah.
1, 2, 4, 3.
Okay, 1, 2, 4, 3. Now, here's a question. Can you get any smaller?
No.
How do you know?
Well, you want to make it in increasing order, but if you want the next largest number, you keep everything else. You keep 1, 2 in increasing order, but then you switch the last 2.
Yep.
So that it's slightly larger, but not by much.
I hope everybody can see that's the next number that you can make, the next largest, smallest number. I guess I should have said smallest here, that you can make with those digits. You keep most of it the same and you just fiddle with the numbers at the end. So we have 1, 3, 2, 4. Is there any number between those two that you can make?
No.
And what about what's the next number after 1,324?
1,342.
Yeah, so notice what we did. We kept the 2 in the same place for these two, and we kept the 3 in the same place for these two. So if you, here, I already prepared some slides about this, so I'll show you. Here's 1, 2, 3, 4. Then we just fiddled with the last 2 digits. Then we moved on to changing the hundreds place, and there's 2 ways to do that. If you kept going, then in order, this would be all the numbers you can make. You can then put 4 in the hundreds place. Now we haven't touched the thousands place. That's all the ways to do numbers with 1 in the thousands place. So then you can put 2 in the thousands place, 3 in the thousands place, and 4 in the thousands place. That gives us 24 combinations altogether. And that's 24 altogether. They're called permutations. And as Jed said, it's 4 times 3 times 2 times 1. And that's because you have 4 choices for the first position, 3 choices, and once you've made that choice, you have 3 choices for the second position. And once you've made that choice, you have 2 choices for the third position. And well, to be mathematically complete, you have 1 choice for the last one. That's not much of a choice. You could leave it off. And as Jed mentioned, that's called 4 factorial. It's got this very funny notation. It's written as 4 by an exclamation mark, which certainly makes you want to say 4, but it's just called 4 factorial. And you can keep going. We've figured out that there are 6 ways to do permutations of the letters in my name, Kim, and that's 3 factorial. 5 factorial, as we already heard, is 120. And you can keep going. There won't be a test, but here's factorials for larger numbers. And here's all the different orders of the letters STOP, following the very same logic that I just showed you for 1, 2, 3, 4. Got O in the first position here, then P, then S, and then T. And 6 of those, which we found, are words. Now, what happens, Jed asked me, what happens if you have two letters that are the same? Now I've taken the liberty of taking Arya's name here. She has two letters that are the same. What happens? How is you can still put them in 24 different orders.
I think I got it. I think the answer is 16.
You think 16? How do you tell me why?
Well, I was just thinking about this. I might be incorrect, but well, so for the first digit, you can start with A, R, I, or A, right? So you can take out the last block on the right. You can just take that out because it's the same exact thing as the block on the left.
Mm.
You can ignore that. So it would be the rest of it would be 3 factorial, right? But then you have but then you have 2 of the same ones because you have wait, let me think. Because you have AA wait a minute. So that's okay, so that right block's gone. And then you have the A, I, let me think.
Yeah, you're working it out. But that's a good point. Once you have A in the first position, then you have 3 factorial for the rest. But putting the other A in the first position doesn't do anything different. So you could, which we have over on the right.
Yeah, and now I remember because so now when you
get
have
rid of those,
then you can have in the middle of the block R block and the I blocks.
yeah.
RIAA and RIAA. So you can take out one of those. And you have IRAA and IRAA. So you can take off one of those. So it's 3 factorial minus 2.
Okay. See, which ones should I take out? Which rows?
RIAA and IRAA.
Okay, so you think, take out these 2. And that'll give you 16. Cool. Okay, so I'll show you another way of thinking about it. Here's a name that appears twice. And all this, it turns out that if you switch to the 2 A's, you get a copy that's not different. So here's AAIR and here's AAIR up here. So another way of thinking of it is that each name appears twice. So if I take out the second copy of each name, it looks like this. This gives me a different order. This doesn't give me 16. How many does this give me? Well, it's half of 24, which is 12. So I'll let you think about it. We're not done. I want everybody to think about, some of this probably made sense. Some of it may have gone too fast. Think about it until it makes sense to you. I want to end by showing you a few other things about permutations. First of all, there's a great song, the permutation and combination song. And Terry, you can put this in the chat, and it'll also be in the replay video that I send you an email. And it goes over this stuff in more detail. Permutations are when order matters, and he gives some great examples. The order of batters, the 9 players bat in, is a permutation of the batters. And the order really matters. You might want to put your strong hitters up front. That's usually what you do. Sometimes you might put some later. Or the winners in a race. Here's 3 people and they're vying for first and second place. That's a more complicated case. Here, again, they're going to be in some order. Combinations, that's the word it's called in mathematics. It's when the order doesn't matter. Like you might want to choose, you go to a restaurant and it says, here's 6 possible vegetables, choose 2 of them. In mathematics, that's called 6 choose 2. And or in a lottery game, maybe there's 50 different numbers you could choose from, and 6 of them are the winning numbers. That's called 50 choose 6. And there's formulas for figuring out what those numbers are. So I'll leave you with these 2 references. If you want to make your own anagrams, and Terry, you can put this, please put this in the chat. There's a great word engine at wordsmith.org. You can type in any word or phrase, including your own name, and find out how many find anagrams. And it'll try to find good words. It won't just spit out every combination. That'd be boring. And here's the permutations and combinations song. Okay, so before I go, any questions?
When do you use when do you use permutations?
That's a good question. Well, when you want to figure out how many choices there are. So as the examples let's see, when's okay, you know, it comes up when I'm doing artistic projects or when I'm composing music. I might want to go, sometimes I'm curious how many, like I have a theme that has 4 notes in it, and I say, well, what other note order could I put the notes in? That's a pretty artificial example, but that's an example. It comes up in probability all the time. So like, it's not quite the same thing, but one thing you might want to know is how many different ways can you roll 2 dice? There's several different ways of doing it. If you care about which dice is which number, that's one answer. Or if you just want to know the sum, that's another question. Or if you want to know how many ways are there to roll 2 dice where the dice are different, that's a different question. So hope that helps. Any other questions? Okay, well, thank you all for coming. It's past 12:30. Thanks for staying around. I'll be sending out a replay. And those of you who want to stay around and talk, please stay around. Take care.